All right, welcome back. And now what we're going to do is we are going to talk about graphing rational functions, right? So looking at the graphs and how to graph rational functions. So we're going to start with this example. This example takes us back to when we talked about using transformations. So one way to graph rational functions is to recognize when they're using basic functions, or our toolbox functions is another way of looking at it. Okay, but here, notice that this is a reciprocal squared function, right? So this, so our parent function, in other words, let's call it g of x, is equal to 1 over x squared, right? So that's our squared reciprocal function, right? So we know what that looks like, right? We know that this looks like this. Okay? We also know that this has a vertical asymptote at 0 and a horizontal asymptote at 0, y equals 0. So x equals 0 and y equals 0, right? So based on what we already studied in the last several videos, we know how this behaves, and we know where the horizontal and vertical asymptotes. And by the way, just so you know, when it comes to horizontal asymptotes, slant asymptotes, or nonlinear asymptotes, either you're going to have, you can't have both slant asymptotes or oblique asymptotes. You can't have both of those and horizontal asymptotes. You're either going to have one or the other. So if you have an oblique asymptote, then you know you're not going to have a horizontal asymptote. Or if you have a horizontal asymptote, then you're not going to have either a slant or nonlinear asymptote. Okay, so again, keep that in mind too. But let's go back to this example. So in this example here, we know how this behaves based on everything in our toolbox that we know now. And so now what we could do is we could use transformations to graph this rational function, right? Because all we know is we know it behaves like this, and this tells us that we have what? A horizontal shift to the left, right? We have a horizontal shift to the left and a vertical shift up 3 units. So a horizontal shift to the left, 2 units, and a vertical shift upward, 3 units. So that means the asymptotes will also be affected the same way. So that means if we want to graph this one, f of x, all we have to do is take the graph of this one and transform it by moving everything to the left 2 units and up 3 units. And so this graph would look like this, right? I'm just going to sketch the graph, right? So the vertical asymptote is going to be moved 2 units to the left, right? So we'll have a vertical asymptote at -2, x equal to -2. And then the horizontal asymptote is going to be moved up 3 units. So we're going to have something like this, and we'll have the horizontal asymptote like that. And then we'll plot, maybe we plot some points here, right? So we know at 1, 1, right? So there's a point at 1, 1 and -1, 1. So that would be also moved up, right? So 1, 1 would be moved to what? -1, 4. So to -1, 4 would be, let's say, right about there. And then the other one, oh, we could also plot this one and move it the same way, or we could use symmetry, right? So symmetry about the x-axis. This is symmetric about it's symmetric about the y-axis, right? Because this is an even function, right? Remember for symmetry in even functions. This is an even function. So we know it's symmetric about the y-axis, which means if there's a point here at -1, 4, there's going to be one at -3, 4. So right about there. And so we know that this is going to do this and this, and it's going to do this and this. All right, that's it. So that's using transformation. It's a little bit of review. And now we'll talk about the guidelines or the steps of graphing rational functions.